Hiya, this video should be a fairly short one. It follows on from the previous videos to do with exercise 6D, which is about solving cubics. Now, in this example here, we have an equation with a cubic in it, but the equation isn't in its regular old usual place. Now, I have to say that exercise 6D question 6 has a whole bunch of different equations, all of which are sort of written in an unusual way. And you really need to find a way of solving these equations in the most efficient way possible. I can't go through an approach for every single one. Well, I could do, but that would spoil your discovery of it in the first place. But generally speaking, this is kind of what you want to do. You want to set it to this. This means left-hand side. So by adding and subtracting terms from both sides, set it so you've got something on the left-hand side equals 0. Then you can factorize it to the left-hand side, then you can solve it. It's almost always, there's multiple ways you can approach these problems, some more efficient than others. This, although it generally works, might not be the most efficient each time. So you should take each question on its merit and ask yourself, what's the most efficient way of solving it? Having said that, let's have a look at this one here. I'm going to subtract 16x from both sides to get 2x cubed minus 16x is equal to 0. Now I'm going to factorize, and please, please, please don't forget the first step in factorizing is to Hookefe it. So what's the highest common factor? To do that, we look at the coefficients first. 2 and 16 has a highest common factor of 2. And for x cubed and x, we just simply take the variable with the lowest power, which is just x. Open the bracket, write down what's left. 2x times x squared equals 2x cubed, and 2x times by 8 will give me 16x, which is equal to 0. Now, you could factorize this quite happily. It's a difference of 2 squares where the second number will be a square root. But look, because it's not that common, I'll just do it slightly differently and say by the null factor law, 2x is equal to 0 and x is equal to 0 therefore. And then I'll keep it zoomed out so you can see it. Let's have a look at the second factor. The other factor is x squared minus 8. Set that equal to 0 and solve it as well. So add 8 to both sides, and I'd get x squared equals 8. And then when I square root both sides, the value of x could either be the negative of the square root of 8 or the positive of the square root of 8, which is why we put the plus or minus before the square root sign. So the square root of 8 is not plus or minus root 8, it's just root 8, but the value of x could be either the positive root of 8 or the negative root of 8. That's how to look at it. Now, I'd like you to pause the video and have a go at rationalizing that square root of 8. It can be simplified. So see how you go simplifying it, and then I'll go through it. So pause the video and do that. Okay, I hope you did that. So if you didn't, then that's an opportunity lost in it. So what we're really doing is we're saying, are there perfect squares other than 1 that go into 8? And the answer is, yeah, it does. 4 is a perfect square, and 4 times 2 is 8. And so this can be written as plus or minus the square root of 4 times the square root of 2. And the square root of 4 is 2, so it's plus or minus 2 root 2. So that's how you rationalize it. And so there are 3 solutions there. There's x equals 0, x equals 2 root 2, and x equals negative 2 root 2. So if I was summarizing it, I could just go x equals 0 or plus or minus 2 root 2. Or if you want to be super explicit, you could say 0, 2 root 2, negative 2 root 2. There's something nice about doing that because it's explicitly stating there are 3 possible solutions, so that when you're graphing it, you can see there's 3. Whereas this one's, it's almost hidden that there are 2 solutions right there. Okay, like I said, it's a short video, this one, so that will do for example 6. Example 7, if you have a look in the textbook, is all about calculator usage. So get your calculator ready, and next video we'll have a look at example 7.